Okay, so hi there folks. In this next video in college algebra, we'll be talking about the difference of two cubes. So remember, in our previous video, we have talked about the sum of two cubes, and then this time it's going to be the difference. So I think you will know what to expect here. And yes, that's it, that it's a difference of two cubes. So there's a minus sign instead of the plus sign when you say sum. Well, that's kind of clear, I think. That's straightforward. So difference referring here, and then two cubes referring to this two cubes over here. Okay, so that's the difference of two cubes. So what is the formula? Actually, it's really the same with the sum of two cubes, only that the minus sign, instead of, if you can remember, the minus sign is over here, and then it's a plus sign here. Okay, if this is a difference of two cubes, again, this is our formula. If it is, or rather, if it is the sum of two cubes, but if it is a difference, erase all, and this is the formula. So basically, it's still the same. So let's try. For number one, we have 64x cubed minus 1. Again, we still need to have some knowledge in cube roots. And what we're going to do, again, is we're going to given the cube root of the first digit, and then the cube root, or rather the cube of the first digit or the first term, and then the cube of the second term. And then what we're going to do is get the cube root out of it, and then follow the formula. So as an example for number one, what is the cube root of 64x cubed? So in short, a cubed here is equal to 64x cubed. So to get the value of a, we need to get the cube root of this. So what number, if you're going to multiply it by itself thrice, it's going to give us 64. Okay, actually that number is 4. If you want to check it, so let's try. 4 squared, we know 4 squared as 16. So how about 4 cubed? That's going to be 16 times 4. So let's try. 16 times 4 is going to give us 4, 24. And yeah, that's 64. So therefore, this is 64 over here. And thus, 4 is the correct answer. And then the cube root of x cubed is just x. And for the b, since it's difference, we just don't need to mind the minus sign for now. And then we're going to put b cubed as 1, and therefore b is also 1. Since 1 multiplied by itself 3 times, or actually for a million times, is still 1. So the cube root of 1 is still 1. So since we know our a and our b values, I think it's much better to put them in a box so that we won't get, um, you won't, you know, we won't lose ourselves. Okay, so what's a? What we're going to do first is write the a minus the b. So what is a? That's 4x. What is b? That's 1 minus 1. And then what is a squared? So squared is 4x. That's going to give us 16x squared. Okay, multiply a times b. So 1 times 4 is going to give us, well, 4x. Or rather, 1 times 4x. It's going to give us 4x. And then b squared, 1 times 1 is still 1. Oops. And yeah, this is the answer for number 1. Okay, so pretty much if you have noticed it, and if you have watched the first video about sum of two cubes, it's pretty much the same. Okay, only that the signs are different. Okay, how about this for number 2? So this is our a cubed. This is a perfect cube. This is also a perfect cube itself. So our a cubed is x raised to 24. Okay. Our b cubed is z raised to 30. Now, what is happening here? So we must remember our law of exponents. Okay, so again, we are getting the cube root of this. And getting the cube root of any number, let me put it here, just a review. Let me use the red ink. So remember that if we have any base or any radicand, okay, raised to an exponent, which is a fraction, imagine a over b, or rather, sorry, a over b. Let's use m over n for this example, m over n. So this is actually equal to the nth root of your b raised to m. Okay, So this is the thing that we're going to follow here. So if we're going to get the cube root of x raised to 24, it will look like x raised to 24 to the third, to the cube root. So we can change this into fractional form, just like this one. It can be written as x raised to 24. Oops, maybe we can put it down below. X raised to 24 over 3. Now, what is happening here? We are dividing the numerator by the denominator. So that is practically just arithmetic. So 24 divided by 3 is going to give us what? 24 divided by 3? That's going to give us 8. And therefore, 8 is our, or rather, x raised to 8 is our answer here. Okay, similarly, with our z raised to 30, we shall follow this same rule. So if we're going to do that, that is z raised to 30 cube root. Cube root of z raised to 30. So how do we do this? Same pattern will be done. So 30 over 3, that's pretty straightforward to be 10. So that's z raised to 10. So therefore, our b value here is equal to z raised to 10. So let's highlight those numbers, shall we? Or these terms. Okay, so to answer our factorization using the difference of two cubes, let's have this. So again, our a is x raised to 8, our b is z raised to 10. So um, it's going to be first a minus b. So we have x raised to 8 minus z raised to 10. Okay, that's it for the first term. And then we're going to square this term, this x to the 8. So how do we square x raised to 8? Okay, so we're going to use again another power, our another law in exponents, that's power of a power. So this is x raised to 8. We are going to square that. So squaring means multiplying the exponent. So this can be rewritten as x raised to 8 times 2, which is consequently equal to x raised to 16. And that's our answer for the first term in this part. In this part. Okay, so this is x raised to 16. And then a times b, multiply x raised to 8 and z raised to 10. So pretty much we just need to copy them. Okay, x raised to 8, z raised to 10. And similarly, in our last term, in this trinomial, in this part here, we're going to square the z raised to 10. So if we do that, what we have is z raised to 10 squared. It's going to give us z raised to 10 times 2, which will give us ultimately z raised to 20. Oops. Okay, and that is our last term, z raised to 20. And yeah, that's our answer. So parentheses. Okay, that's our answer for number 2. Okay, I hope you got it right here. Okay, so let's move on and continue with our answers in numbers 3, 4, 5, and 6. Let me fix this. Okay, now for number 3, same thing. What's the cube root of this, and what's the cube root of this? But first, we need to make sure that they are perfect cubes, and in which they are. So a cubed is equal to 64 x cubed y cubed, and b cubed is equal to 125. So what is a? What's the cube root of 64x cubed y cubed? So we know from the previous example that the cube root of 64 is 4. So we're going to follow that here. This number 3. It's going to be 4. Cube root of x cubed is x. Cube root of y cubed is y. And the cube root of 125 is 5. If you want to check that, so we have 5 squared is equal to 25. 5 cubed is equal to 25 times 5. So 25 times 5 is going to give us 10, 25. Yeah, that's pretty much 125. Okay, so that's going to give us 5, surely. So let's have that. Okay, so this is our A, that's our B. And yeah, let's follow this formula here. A minus B, that's 4xy, okay, minus B, which is 5. So we have 4xy minus 5. And then we're going to follow this trinomial formula here. So what's A squared? So square 4xy, so we have 16x squared y squared. Multiply A and B, so we have 4 times 5 is 20. Copy the variables, so we have 20xy. And then the square of 5, we know that as 25. And yeah, this is our answer for number 3. Okay, how about for number 4? So let's move this a bit up. Okay, so we have this is a perfect cube. This 1000 is also a perfect cube. So we're going to follow this formula again. So we have a cubed is equal to t cubed, and our b is equal to 1000. Okay, so what is the cube root of t cubed? So pretty much that's just t. What's the cube root of 1000? So that's 10. Okay, 10 squared is 100, so 10 cubed is 1000. So following the formula given here, so a minus b, that's t minus 10. Okay, t minus 10. And then square the first term, that's t, that's going to give us t squared. Multiply t and 10, so we have plus 10t. And then square the 10, that's going to give us 100. Okay, and that's pretty much our number 4, and that's the correct answer. Okay, moving on to number 5 example. Okay, I think this is our last slide for examples. More examples, more practice and more chances that we can learn this. If you have some difficulties or more difficulties, you can always rewatch and replay. Okay, so this is a perfect cube. This is a perfect cube. How is this a perfect cube, sir? Let's try 11. 11 squared is 121, and 11 cubed, not 11 cubed, sorry, 11, yeah, 11 cubed, I wrote 13. So that's 121 times 11. If you know the Vedic methods, it's going to be 1, 3, 3, 1. That's our answer here. And this is, let's just write it right now. So 1, 3, 3, 1 is just the cube root of that is 11. And here we have our a cubed is equal to m cubed. So our a is just equal to m. Okay, since we know already our a and b, let's put that in a box, shall we? And yeah, let's answer. A minus b, so that's m minus 11. M minus 11. And then square the m, that's going to give us m squared. Multiply m and b, so that's going to be m and 11 rather. 11m, that's going to be 11m. And then square 11, this is the answer that we're looking for. That's 1, 2, 1. And this is our answer. Okay, so that's for number 5. For the last number, at last, so we have 64a cubed and 8. So they're both perfect cubes. So a cubed is equal to 64a cubed. Got the cube root of that. We know 64 as the cube root of it is 4, and a cube root of a cubed. For our b cube, the answer here is 8, and then the cube root of 8 is 2. Okay, so 2, 4, 8, fourth root of 2 is 16, and so on. So let's apply these values to our formula. Okay, and then follow this formula here. Okay, so a minus b, 4a minus 2, and then square the first term. 4a squared is what? 16a squared. Okay, and then a times b. is 4a times 2 is plus 8a. And then lastly, square the last term, which is positive 4. And that is our answer for number 6. Okay, so pretty much that's our difference of two cubes. I have presented here in this lesson 6 examples. You may want to pause and recheck. We just have some recall here, or just some review in exponents. Hopefully you still remember them on radicals. And then for power of a power, we have has a smooth transition for 3 to 4 and then 5 to 6. Okay, so hopefully you got that lesson, and hopefully you understood now how to do the difference of two cubes. Again, this is very similar to the sum of two cubes, only that, well, this is the only difference. It's the word difference. Okay, okay. That's kind of good. The only difference is the word difference. Okay, so that's it. Enough of me. Okay, so thank you very much for watching. Don't forget to like and subscribe. Okay, see you. Bye.